Hello, good morning. Unit 3, System of Classification. Unit 3, 1, Acid, Base, and Salts. This is the curriculum of acid, base, and salt. Characteristics of acid, base, and salt. Acids have the taste, sour taste, for example, lemon, vinegar, and base have the bitter taste, soap, baking soda. Litmus paper taste, in case of acid, blue litmus paper turns into red. In case of base, red litmus paper turns into blue. A reaction with metals, acid reacts with active metals, for example, zinc, magnesium, to release the hydrogen gas. In case of base, usually it does not react with the metals. Reaction with carbonate, in case of the acids, reacts with the carbonates. For example, calcium carbonate reacts with acid, release the carbon dioxide. In case of base, does not react with the carbonates. pH, below the pH 7 is the acid, and greater than 7 pH is the base. Ionization in water produces hydronium ion is the acid, and hydroxide ions produces in case of base. Electrical conductivity, acid conducts electricity, that is the electrolysis, and also conducts base, the electricity. Typically no distinct film, but can be corrosive in touching, that is no distinct film, but acid is the corrosive. But base are slippery or soapy feel in touching. Neutralizing reaction, and acid reacts with the base to form the salt and water, and the base reacts with acid to form the also salt in water. For example, hydrochloric acid, sulfuric acid, acetic acid are the example of acid. Hydrochloric acid and sulfuric acid are strong acid, and acetic acid is the weak acid. Ammonium hydroxide, potassium hydroxide, sodium hydroxides are the example of base. Ammonium hydroxide is the weak base, and sodium hydroxide and potassium hydroxide is the strong acids. Artist's concept of acid and base. Acid are defined as the compound that releases the hydrogen ions into the solution is called the acid according to the Artist's concept. For example, nitric acid produces S plus ion in water. So nitric acid is the acid. Similarly, sulfuric acid, hydrochloric acids are the acid because it produces S plus ion in water. In this reaction, nitric acid dissociates into hydrogen and nitrate ions when dissolved in water. Okay. Artist's concept of base. Base are defined as the compound or element that releases the hydroxide ions into the solution. For example, lithium hydroxide is the base because it releases the hydroxide ion in solution. Similarly, sodium hydroxide, ammonium hydroxide are the base because it releases the hydroxide ions. In this reaction, lithium hydroxide dissociates into lithium and hydroxide ion when dissolved in water. Limitation of Arrhenius concept. The concept does not explain acidic and basic character of the substance in non-aqueous solvents. It cannot explain the acidic character of certain salts, such as aluminum trichloride in aqueous solution. It's also called Lewis acid. Uh, Bronsted-Lowry concept. Bronsted-Lowry concept is the proton hydrogen ion donor is the acid, and base is the proton hydrogen ion acceptor. Hydrogen acid is the proton ion donor, and a proton Bronsted-Lowry base proton hydrogen ion acceptor. For example, hydrochloric acid and ammonia are the acid and base because hydrochloric acid releases the hydrogen ion, or it donates the hydrogen to the ammonia, and ammonia is accepts the hydrogen ion. So as hydrochloric acid is proton donor and acid, ammonia is the proton acceptor, that is the base. Limitation of Bronsted-Lowry concept. The protonic definition cannot be used to explain the reactions occurring in the non-protonic solvents, such as bleaching powder, sulfur dioxide, etc. Substances like boron trifluoride, aluminum trifluoride, etc. do not have any hydrogen and hence cannot give a proton, but are known to behave the acids. I have already discussed aluminum trichloride is Lewis acid. It acts as the acids, but in this example, there is no any hydrogen, so it cannot explain about the acidic behavior. Conjugate acid and base. Conjugates are formed when an acid loses a hydrogen proton or base gains a hydrogen proton. Conjugates of acid and base are formed when acid loses the hydrogen proton and base gains the hydrogen. See, this is the base. It gains the proton, that is the conjugate base, and acid loses, this is the conjugate acid. Right, short note on Lewis concept of acid and base. Lewis concept of acid and base. Acid are electron acceptor and the base are electron donor. Ammonia is Lewis base and hydrochloric acid the Lewis acid. C is the ammonia. It accepts the proton, and hydrochloric acid ammonia have the lone pair of electron. It donates the electron to the hydrochloric acid. So ammonia is the electron donor. That's why it is the base, and the hydrochloric acid is accepting the lone pair of electron. So hydrochloric acid is the electron acceptor. That's why it's the acid. Limitation of Lewis concept. It does not explain the behavior of the well-known protonic acids as hydrochloric acid, sulfuric acids, as we do not form the coordinate bonds with base. It does not explain the relative strengths of acid and base. Salts are chemical compounds formed by the neutralization reaction between acid and base. For example, acid and base produce salt in water. Sodium hydroxide and hydrochloric acid reacts to form sodium chloride salt in water. Types of salt. There are different types of salts, namely acidic, basic, neutral, and double salt, also mixed salt. Acidic salt that is formed as a result of the reaction between the weak base and a strong acid is called acidic salt. Ammonium chloride, copper sulfate are the acidic salt. Hydrochloric acid is the strong acid, and ammonium hydroxide, the weak base. It reacts and produces ammonium chloride. Ammonium chloride is the acidic salt. Basic salt, similarly, a salt that is formed as a result of reaction between the weak acid and strong base is called basic salt. Sodium sulfite, sodium acetate are the basic salts. Acetic acid is a weak acid, reacts with a strong base, sodium hydroxide, produces sodium acetate is the basic salt. Neutral salt, a salt that is formed as a result of the reaction between strong acid and strong base, is called neutral salt. For example, sodium chloride, potassium nitrate are the neutral salt. Hydrochloric acid is strong acid and sodium hydroxide is strong base and produces sodium chloride is the neutral salt. Double salt, a salt formed with the equimolar proportion of the two simple salts when they are crystallized at the slow phase and form a mixture of their saturated salt solution. For example, potash alum and more salts are the double salts. In this case, in case of potassium, potassium sulfate and aluminum sulfate have the equimolar proportions and form double salt. Similarly, more salt, ferrous sulfate and ammonium sulfate are equimolar proportions. See, 1 mole of potassium sulfate in 1 mole of aluminum sulfate heated up to crystallization point and form potassium. This is the double salt. Mixed salt, a salt that contains more than one type of cation or anion atom in their composition is called mixed salt. For example, bleaching powder have the two types of anions. One is the oxide and another one is the chloride. Similarly, in case of potassium ferrocyanide, there is two types of cations. One is the potassium, another one is the iron. Uses of the common salt, common uses of the salts, table salt, it is also called common salt, used as the flavoring and preservative in foods. Epsom salt used in the medicine, agriculture, and baking soda used cooking, cleaning, and as an antacid. Potassium nitrate used in the fertilizer and fireworks. Calcium carbonate used in the construction as a dietary supplement and antacids. Neutralization reaction. A neutralization reaction is when a acid and base react to form water and salt. For example, hydrochloric acid and sodium hydroxide react to produce sodium chloride in water. Amphoteric substance or chemical species that behaves both as acid and base is called amphoteric substance. Water is the most common example of acid as the base when reacting with an acid such as hydrogen chloride. Water reacts with hydrogen chloride. It acts as the base and produces hydronium ion and chloride ion. Also, it acts as the acid reacting with the base. Water acts as the acid when reacting with base ammonia, producing ammonium and hydroxide ions. pH of solution, it is defined as the negative log of the hydrogen ion concentration in molarity of base 10 or pH equal to minus log S plus. pH scale, the pH scale is the numerical scale used to measure the acidity or alkalinity of solution 0 to 14. If the pH is 7, it is the neutral, and lower than the 7, the acidic, and higher than 7 is the alkaline or basic. Acidic solution, the pH with the lower than 7 pH and high concentration of S plus ions. For example, lemon juice have the pH 2, vinegar 3. Neutral solution, the solution with the pH equal to 7 and equal to concentration S plus and hydrogen ion and hydroxide ion. Example, pure water. Basic or alkaline solution, the solution which have the pH greater than 7 and low concentration of hydronium ions and higher concentration of hydroxide ions. For example, baking soda, pH 9. pOH solution, it is also defined similar to the pH. It is the negative log of the hydroxide ion concentration in molarity. pOH equal to minus log with minus hydroxide ion. Relation between the pH and pOH, the relation pH and pOH from the constant of water expression is the hydrogen ion for hydroxide. It's also pKw, pH, pOH. At 25 degrees Celsius, the value of Kw is 1 into 10 to the power minus 14. So 14 equal to pH equal to pOH. The pH value of solution of sodium hydroxide is 10. Calculate the hydroxyl ion concentration per liter assuming complete ionization. We know that pH equal to minus log H plus. So H plus equal to 1 into 10 to the power minus 10. Now ionic product of water H plus hydrogen hydroxide ion equal to 1 into 10 to the power minus 14. So hydroxide ion equal to 1 into 10 to the power minus 4. Calculate the pH of 0.001 molar hydrochloric acid and 0.005 molar sulfuric acid solution, assuming the complete ionization in each case. First of all, you should dissociate the species, that is the hydrochloric acid in case of first, and second sulfuric acid. So hydrochloric acid dissociate is H plus and hydronium ion chloride ion. Then after we should balance, it is automatically balanced. So 1 mole of hydrochloric acid produces 1 mole of the hydrogen ions. So pH equal to minus log H plus. So H plus 0.001. So that is the 3. Similarly, in case of sulfuric acid, the dissociate is 2H plus SO4. So 2 mole of the hydronium ion. That's why pH equal to minus log is 2 into 0.005 equal to 2. Calculate the pH of the solution containing the 2 gram per liter of sodium hydroxide. Molecular mass of the sodium hydroxide 40 gram. Number of moles, weight in grams, molecular weight 2 into 40 equal to 0.05 mole. Sodium hydroxide dissociate sodium plus and hydroxide ion, and is also balanced in equation 1 mole. That's why hydroxide ion is 0.05 mole. So we know that S plus OH minus equal 1 into 10 to the power minus 14. So S plus equal to 1 into 10 to the power minus 1 hydroxide ion. That's why in the solving pH equal to 12.699, 12.7. Calculate the pH of the flowing solution for 0.005 molar sulfuric acid and 0.001 molar sodium hydroxide. Sulfuric acid dissociates and it's the 2 mole. That's why pH equal to minus log 2 into 0.3. And similarly, sodium hydroxide dissociate and OH equal to 0.0051. POH, we know POH equal to minus log hydroxide ion. That's why minus log 0.001, that is 3, and pH equal to 14 minus pH, that's why pH equal to 11. What is the pH value of 0.05 molar sulfuric acid? Sulfuric acid dissociate hydroxide ion plus sulfuric acid 1 mole 2 mole, that's why pH equal to minus log H plus minus log 2 into 0.05, that is 1. Buffer solution or buffer solution is the special type of solution that resists the change in the pH when a small amount of acid or base are added. Typically, it consists of weak acid and its salt, its conjugate base, or weak base, its conjugate acid, that is salt. Types of buffer solution are acidic buffer solution, a mixture of weak acid and its salt is called acidic buffer. For example, sodium acetate and mixed with acetic acid, it produces the acidic buffer. If you add a small amount of acid or base, the pH does not change in this mixture. That's why this is the buffer solution. Similarly, basic buffer, a mixture of salt made of the weak base and salt is called alkaline buffer or basic buffer. Ammonium hydroxide is mixed with the ammonium chloride and ammonium hydroxide mixed with the ammonium sulfate. It's the basic buffer. Thanks for watching. It's all about acid, base, and salt. Unit 3, system of classification, acid, base, and salt. Diploma in computer engineering, first semester. and request you all like, comment, share, and subscribe. Thanks for watching, and thanks for your patience. That is now. Bye bye. See you again.